Evaluating the limits at x go to negative or positive infinity is to determine the end behavior of the function. For part A, the limit at x go to negative infinity of x squared plus 5. Observe that if x go to negative infinity, then x squared will go to positive infinity. The way that we look at it is that if x is a very large negative number, when we square that negative number, we will end up with a positive number, and a very large number squared is still a very large number. And then we take this large number and then we add 5 to it. Then this large number is still very large. And so we say that this is infinity. Infinity is not a number. What we're saying here is that this function increases without bound at x get arbitrarily large negative. On the graph, if we go all the way to the left, then the graph will simply go up indefinitely, and that is positive infinity. Again, infinity is not a number. This symbol indicates that the limit does not exist, but it does not exist in a special way. How special is it? It is increasing without bound. For part B, the limit at x go to positive infinity of 60 plus e to the negative x over 2 minus e to the negative x. We'll also observe that at x go to infinity, then e to the negative x can be rewritten as 1 over e to the x. And this is 1 over, again, x is very large, and so e raised to a very large number is still very large. But 1 over a very large number is almost 0, very small. And so what we have here is 60 plus almost 0 over 2 minus e to the negative x, which is almost 0. Think of this as this is going to 0, and this is going to 0 at x go to positive infinity. What we end up with is 60 over 2, which is 30 as the limit. For part C, the limit as x go to infinity of 2 over 5 minus 5.3 times 3 to the power 3x. In this case, similar to the previous two cases, at x go to infinity, then 3x also go to infinity. If x is a very large number, then 3 times a very large number is still very large. Now, if we take 3 raised to a very large number, then it is still a very large number. And so what we have here is 2 over 5 minus 5.3 times a very large number. And a very large number times negative 5.3 is still a very large number, but this is now negative. If we add 5 to that very large negative number, then the number is still very large, but still negative. And so what we have here at this step is that 2 over a very large negative number, but 2 over a very large number is almost 0, very small. And so we say that this limit is 0.